This video will continue our discussion of double integration by finding the volume of a shape over a certain plane. So we have this double integral over R. They gave us R here. Now this is going to be a bit different. Our X values here definitely, that's weird that it's doing that. The X's are between 2 and 4. Alright, but this is the different part. Y now is between 0 and now a function. Alright, this is just like setting it up in Calc 1, but they would give us like a... They would draw this part for us and then tell us to find the area. But now we're going to let this be our region. How I figure this out, I know that X is going from 2 to 4. I like to keep it pretty straightforward, and I just plug in those values. So if I plug in a 2 for this function, first let's do this. Maybe you don't recognize what that is. I think sitting like this, I'm like I can tell you a bit by it, but I need to go a little further for my brain. If I factor out a 4, I have that, which is 2 square roots of x minus 2. I can see this function now. It is something like this, moved over at 2. So I actually can tell, and we could even plug the value in. If I plug in 2 into that function that we just came up with, right? If I plug in 2, I get 0. If I plug in 4, I get 2 squared to 2. We don't really care about it being accurate. I just need to see in my brain what it kind of looks like. So I'm going to put 2 squared to 2 right there. And I'm going to worry about scaling the y-axis. And then I can actually capture the shape on here without having to get too detailed. It looks something like that. And then I know that the region that I'm trying to capture, right, if it went straight down, I missed a bit there. Here we can just cheat and make that 4 scoot over. There we go. Okay, so that's considered the 4 now. Just cheated and did that. So the region is caught, and because it says y is from 0 to that function, right, then I'm actually caught inside of here. So it's everything in this region right there. So it'd be like us having, I know I keep relating it to a yard, but it makes a lot of sense to me. If I had a yard or a sandbox, I guess we can change it. That's a sandbox and a weird thing, and we have some surface. This models the sand, the height in that region, and I'm trying to find how much sand is inside of there. All right, so we have to set this up. The deal is we're trying to find a volume, so we really prefer to have a number come out of all of this. What I'm trying to say here is if I'm setting this up and I have to determine which one goes first, x or y, I want to put my x here because at the very end I'm going to be plugging in a 4 and a 2, which means that I'm going to get a number out. But y is caught between 0, and we could see this. We should start looking at the pictures here, even though this one's maybe obvious what it's caught between. But it's caught between y equals 0 and that function. Right? So, and we're going to have to keep drawing this arrow, and it's going to get a little more complicated as we go along. But right now, we can see that it's y equals 0, which is the x-axis, up to our function. I'm going to put in the factored form. This is going to help us out here in a moment. I keep the same integrand. Nothing changes. And then I have to write these in correct order. dy dx. All right, we're focusing on the y integral first. So I'm going to leave the x1 alone. All right, and we can go ahead and integrate that. I'm going to put the 1/3 on the outside. Where it comes from is if I raise, I'll write it here and then I'll erase it. We raise the degree up by 1 and we divide by the new one. So to save us some room, and I know a lot of you guys want to do stuff like this, I'm going to pull that 1/3 out. And then I'm just going to put x, y cubed. The 1/3 just went outside. We already did our integrand with respect to y, so now I'm going to put y equals 0. This is why it's important to put your y equals here, is because I see students do it. I still have students that won't write it down. And what ends up happening is they don't write this down. Let me erase these and I'll undo it. And then they plug it into x. And it's just because they're working too fast or not thinking about it. So I have found if I put y equals there, I don't plug it into x because it says y. So if you can get by without doing it, that's how curriculums are approached without doing it. That's perfectly fine. I prefer to do it this way because I know I mess it up. All right, so this is x equals 2 to x equals 4. Now, I'm going to write this off to the side to just kind of help you understand what's going on. This is 2 square root x minus 2, and we're going to plug it into the 3rd power. All right, the 2 to the 3rd is 8. That's fine. But what happens here, we could write it like this, x minus 2 squared. and then I'd have another square root of x minus 2, right? This is to the first power, so if I put them back together, I'd have to the third power. Well, that tells me that this is 8x times x minus 2, and then the square root of x minus 2. So that's what's going to go in here. 8x times x minus 2 times the square root of x minus 2. All right, that was plugging in this part. If I plug in y equals 0, it's gone. We'll put it for note's sake, minus 0. And I still have my dx. So I'm going to erase all this over here. All right, this is kind of a trick here. You do this when you're learning integration, and I know when I teach those classes, my students just don't see this. So if I do u equals, I'm looking at that, I see 2x minus 2. So if I do x minus 2, that's going to cover this inside, but I got this x that's hanging out, and I need everything to be u. Well, I could just solve this equation. Well, let's do this. du equals dx, so I won't need a replacement there. It's just a dx straight across. But I could solve this and get x equals u plus 2. So what this is going to do, and you're like, well, cool, we switch all that, but why? Well, the problem in my integral right now is right here. That's really dark. Let me turn that off. Is right here. I can't integrate with that square root, right? It gets weird. You can't, chain rules mess it up. So if I do this kind of plugging it in with those u's, okay, we'll check it out. I'm going to take that 8 outside. Let's go ahead and change our x values to u's. So if x is 2, I just go right here. If x is 2, u is 0. If x is 4, u is 2. The 8 I pulled out. And then this is where it gets nice. Okay, that x becomes a u plus 2. That's great. That's not a big deal. Then I have times u. And then I have times the square root of u. That's where that's nice, because now this becomes u to the 1/2. And then I have du, because it's just a straight trait. That now gets rid of the weird square root, because I can just put one term, and we can actually do some exponent arithmetic with it. So let's go ahead and do that. I'm going to put stuff together. Okay, so we get, I'm going to do this a few steps at a time so you guys don't get lost. I got u to the 3/2. That's this 1 here plus 1/2. That's going to then be distributed. All right, so I got 8/3. From u equals 0 to u equals 2. You could just put numbers now because all we have are u's. And I got a 1 here. So that's 2 over 2 plus 3 over 2. That's u 5/2 plus 2u to the 3/2 du. Now that's easy, just the integration rule. So we got 8/3, and now we're going to take the integral. Okay, I go up by 1, that's 7 over 2. If I divide by 7 over 2, that's 2 over 7. That's using our integration rules. If you need to go review, please go review. That's just the power rule for integration. Up by 1, and in my power now, 3/2. If I add 2 over 2, I get 5 over 2. That's 2/5, but there's a 2 there already, so I get 4/5. Clean that up. 4/5. U to the 5/2. We're running that between 0 and 2. We're not going to get a clean answer here, so this will be our answer. I'm not going to simplify anything because nothing's really going to get better. It's still going to look gross. This would be something I'd just plug into my calculator if I really needed the number. So that's plugging in 2. And then I would minus plugging in zeros, but that just zeroes everything out. So there's my answer. Practice this integration. I know if maybe you were thinking this already, but like in the last couple of videos, here is a good place you could plug in your calculator. That's fine at that point. I say practice integration because you really do need to practice it for DiffEQ if you have to take that. But you are allowed to use a calculator. The calculators I allow on my test will allow you to plug that in. It will not allow you to plug the double integral in, though. You have to get down to the first integral. So you are doing Calc 3 things by doing the double, and then at this point, it's just a Calc 1-2 problem, so I don't really care if you plug it in or not. So, yeah, there we go.